Appreciate the opportunity to talk about the UFS here. I'm going to be strapped a little bit for time because we just had a workshop on the UFS for 4 days and 450 people there. I have to condense that in 15 minutes. We'll see how well we're doing with that. So the big picture of the UFS, the idea is that within NOAA at least, we want to have a forecast system that we use for both research and operations. That way align research better with improving operations. The idea is to do this evidence-based decision-making to make sure that there is predictability in what we will put in operations and what we don't do. What is really important about the UFS is that we considered it not as just as a software stack, but as a set of applications. Since applications have either research or operational outcomes, the focus on application and just on the software stack is really, really important, and is, for instance, sort of a bit of a difference between the original, for instance, WRF community, where the community would really focus on the software stack and on little pieces of that rather than on full applications. This is something we try to avoid here. The idea is to have a unified system because we share infrastructure and applications. This is not a unitary system. The goal is not to have a single monolithic system. The goal is to create the proper focus on a few applications so you have critical mass, while at the same time maintaining the diversity you need for research in general. And for us, it's really a paradigm shift. NOAA has historically, particularly at the NSAP side, worked with their own models. Instead of trying to work with their own models and getting other people to work with it, the idea is to create a community where the community models are the ones that drive operations. So next slide, please. So for the community scope, these are sort of the different timescales we're looking at in applications. Like I said, application focus is really important because application focus means you have outcomes either for research and for applications, for research and for operations. Note that this is the original span from the weather side going up to a year or two. There is nothing that stops us from going to decadal and centennial. And if you look at internally within NOAA, GFDL with their decadal and centennial work, considering themselves full members in this unified forecast system, full partners in this unified forecast system. So in some ways we could extend this to decadal and centennial too. From the operational perspective, it is really a question about us being pushed for many, many years to simplify what we're doing. The top left is what we call the quilt from about 4 years ago, which is only showing the major systems in our operations that is way, way more complicated than anything that any other operational center is doing. And it's not because we want to do it, but because we're told to do that. By going from a system where we built a system that was, the governance was based on trying to get individual solutions accepted for operations, created this set of little stovepipes. What we're doing right now is moving to a requirements-based operational forecast system, which really means that you first look at the type of products you need and then figure out how to technically get solutions for that. And so the right side is sort of the top end of what that would look like. The whole production suite would look like after we've come to full conversions. That is easier said than done. On the left side here, you see the 20-some major systems we have in operations right now. On the right side, we have the unified forecast system applications that we want to concentrate on. And you can see from left to right, we go through all kinds of timelines to simplify these things. And the black box in the middle is the fact that we're going to change our computer system, which will be about a year of a moratorium for putting stuff into operations, but also gives us the chance to have our researchers work on actually developing code and rather implementing it. The two things to really look out here is the two red circles. On our GEFS side, we are now having both aerosols and waves fully integrated in the GEFS that is actually implemented today. The next GFS implementation also will be a coupled system where we're coupling the global model to the wave model, which effectively means that we have reduced the amount of applications we have in our production suite by 3 and starting to make real progress into simplifying the production suite. And it's kind of interesting to look at this from a systems perspective. Previously, we were talking about coupling from a science perspective, and there was a lot of pushback because the engineering would be much more complicated. Now we come to the conclusion that if we use coupled systems, we have less applications, and we have, even though the applications are more complicated, a much easier to maintain system. And so we went from to a argumentation where even if we only do one-way coupling, we couple some of these applications already. And even with one-way coupling, you get a lot of benefit in terms of reducing the amount of disk I/O between systems, being able to run things side by side, and getting a much better input time resolution for what used to be the downstream models. A key element for this is the fact that we're not doing this alone. About a year and a half ago, we actually signed a formal memorandum of agreement between NCAR, Weather Service, and OAR. And this builds upon a lot of work we already did with a lot of other partners, as you will see in the following slide. Please keep this one up still. The UFS working groups are already engaged, even when we're talking about designing this MOA. And it's too hard to see on the right side, but this is signed at the level of the directors of the Weather Service and OAR, and the directors of NCAR and UCAR. These are the 7 different fields that we're talking about, and this tells you how big this effort is, because particularly the talks from Rocky Dunlap and from Marianne Furtenstein are going right into the core of what we're doing here. We basically use ESMF and UOPSI, as well as CMAPS and further development of NEMS as the coupling of components. We are looking at doing intercomponent coupling by standardizing, for instance, the physics interfaces for the weather model. The focus is really here on the physics for the weather models. Things like CICE and WaveWatch already have a similar standardized interface set. The thing that is really the hardest nut to crack right now is to work on a community-friendly workflow. The problem that we have right there is that requirements for community-friendly and for operations are not necessarily completely aligned. We're struggling with that a little bit, but we're having good conversations and are working towards a better system. But this is for us one of the most critical things to deal with over the next year or so. We had already some remarks about the hierarchical model development capabilities. Things that are really important for that is something that Mariana talked about, the CDEPs that allows us to seamlessly change active components with just data modules in a coupled system. That means that if I develop my old wave model, I can do that in a fully coupled environment, coupled to an ocean and an atmosphere, but I can use exactly the same environment for compiling and running by just switching the dynamic atmosphere and dynamic ocean to simple data models, which means that I can do exactly the same level of development that I used to do with the individual component model in completely the same environment. So this is a key element of being able to do hierarchical development, which in turn is a key element in terms of going forward in a smart way with getting better coupled models. One of the other things that is really important here is the fact that we have working towards a unified verification capability with MET Plus from NCAR, and as of last year, the UK Met Office is one of our partners in this, or earlier this year. This is still more focused on the atmosphere only, but we're building out so that all the other components are being covered in MET Plus also. We have made a really a complete switch over for all our shared software now. All that is in GitHub. It is very similar, sort of an organic set of repositories of components and infrastructure has been shown in quite a few of the previous talks. And then, of course, one of the real hard parts of this is to do the user support with this, and I'll come a little bit to that, some of the things we've done. Just to show you how much this is not just a NOAA thing anymore. This is just a little graphic show that Cecilia DeLuca generated for us for the AMS meeting. Shows you a lot of different components, shows you a lot of different collaborators, both in the government and in industry and in academia. And oh, by the way, this also showed what Rocky mentioned a little earlier. the idea of have a JEDI data simulation driver over top of the coupled modeling driver. So the key elements of these things is not only for operations to be simpler, but to be able to have research and operations work with the same type of software, exactly the same software where possible. So we spend a lot of time on getting a UFS release, formal UFS release out. This is basically just to show you the different type of thing, the 7 different focus teams we had for that, and the fact that we have a very broad group of people working on that, and that we have leads from both operations, which we are on, from development side from Mariana on the NCAR side within the MOA, and then DTC is really the outreach part that worked on that. So next slide. The strategy is to do the first release with the weather application that was done on March 11th of this year. You can read just as fast as I can talk. So this is basically the set of models that we have. It's not just the operational model. It is a set of models with different resolutions that allows you for hierarchical development. Similarly, the CCPP allows you to actually run this with, if you want to, with other physics bits and pieces too. What is done with this is that we don't have the DA part here yet, but we give you access to initialization of this model after January 1st, 2018 through web interfaces. The next release was going to be a standalone regional model, which is likely going to be in November, whereas the coupled system is not officially released yet, but is available to the public, as I will show later. Next slide, please. Here are an idea of what the support structure of this is. We are running this on NOAA machines and on other machines. And one of the main reasons for NOAA to do this is that we've had so much trouble getting collaborators into our system that we came to the conclusion that it was much easier to make our system portable and bring the system to collaborators outside of our firewall, because of the issues that we have with being considered a critical national asset. Does not allow collaborators into our system. What is really the game changer here is that it took Neil Jacobs, a team of 4 or 5 people, 4 months on buying a supercomputer to get a GFS to run. You can now do this within 6 hours with the graduate student test, and this is actually done with a coupled model, the coupled prototype. These are the elements that are in this coupled system already, all with a new UPSI and an ESMF and new UPSI cap. And the next slide will show you some of the coupled systems that we have available for this. This includes like the ENES-RI Wavewatch 3 uncoupled, as well as an FE3 MOM6 CIS Wavewatch, more traditional coupled system. So ENES-RI Wavewatch 3 is on a fully unstructured triangular grids. This is a really big deal, particularly the coupled system. There's about 50 people or so working on this, and these systems are available in terms of the getting into the GitHub, but they're not fully supported like the release, and we're looking at that for next year. I just want to show, you can read this as far. I was going to show some results of our coupled seasonal to subseasonal system. You can read this later if you want to. These slides are available. Next slide, please. We are incrementally benchmarking this. We're basically doing an atmosphere, ocean, ice, and wave model component. The power of this is here, and this is a little bit of a busy slide. The observations are CS extends from the black lines. Our CFS system shows the hairs going off there, a significant amount of drift away in the first 35 days. The prototype coupled system, which is MOM6, CIS5, FE3, out of the box, basically had no more drift left, and there are some issues with initialization, but even without any tuning, we were going forward very rapidly with a useful system, and this system is our prototype for our next subseasonal and possibly seasonal system that we hope to implement in a few years. There is a commitment of NOAA to really support this as a community. I cannot talk about that in much detail because we are in the process of awarding a contract for that. If you want to know anything more about this, there is a link. That is all I can talk to you about. But U.S. acquisition law does not allow me to talk about that in much detail right now, unless I would trip up the process of getting this contract awarded. So these are the takeaways. We want to do a unified system, not a unitary system. It's a better business model for both research and operations. because operational models can be world-class research tools. And if you use this if you do your research and development with the same codes that are in operations, you speed up the R2O process by as much as a factor of 5. If you don't believe that, I'll gladly show you the data for that offline or later. And it's also really important that if somebody puts something new in an operational system, we don't create a new stovepipe, and that means that O&M is essentially free in operations. There are initial capabilities. It's weather-focused right now. The regional model will be there soon. But if you're signed up for the graduate student test, you actually have access to the coupled system. And there is a lot of buy-in from the community. There were 50+ papers on the AMS meeting in Boston, and we had 450+ attendees at the 4-day UFS virtual workshop in July. Hope I have some time for a question or two.